Roland here, and just talking about the history of this magnetic energy system, where he uses some neodymium magnets and some really intelligent switching to recover magnetic recovery of energy. And just a little bit about the history of what Paul's been doing and how he's learned about magnetism and how to engineer systems to use magnets to actually do real power and to recover and mitigate Lenz's law to actually take the back EMF and use that as power instead of heat losses and other things, and how to do real science with magnetism, and that's reproducible and scalable. And one of the things he was talking about is after learning through many, many years of, look at this work he's done. This is really detailed work. This is all built by hand back in 2000, 2001.
2001 to 2004, yeah.
Yeah, and so, yeah, just a little bit more about the history on that, Paul, of your experience.
Yeah, well, like I say, we're all industrial dogs, high levels of electronics and industrial electronics experience. I mean, years and years in the field and business and all over the world, high level.
Right.
From a two-way radio shop to some of the biggest corporations in the world. So we have the electronic skills and the physics skills.
Yeah, you understand traditional electronics, traditional components. Obviously, you've started all these.
From tubes in the 30s all the way to the latest, most sophisticated industrial and
just the whole array.
Everything. Everything.
Yeah.
And, because my brother and I, we lived and breathed electrons since we were little kids, and we both went into the professions in it. And we didn't spend a lot of time, we both have, 2 and 3 year degrees, master technician's degree, but we taught ourselves engineering and went way past most engineers in skill and work history, everything, experience, everything and anything.
Eventually you saw through your experience that magnets could be harnessed potentially to do work.
Yeah, it all started out in Alaska in 1988. I'd been researching Tesla and Beard and all those guys for years. Yeah. And I'd been trying to find a whole, because we had all seen these effects out there in industry where did that come from? Unexplainable. Right. Engineers.
And everything is explainable at some level. You have to.
Yeah, exactly. And so I was looking for different things like holes in Ohm's law, which there is none. And then one day I got hurt one year. I was working in Alaska in the fishing industry. I'd work in the summers, go to Hawaii in the winters. Well, I got hurt.
I did that.
And wound up broke. Doctors got all my money. Had no luck at all except for bad luck. And so I'm sitting in my little cabin, broke, and this guy came on the radio doing an interview, Joseph Newman, right?
Oh, okay.
And he started talking about
on Coast to Coast or something?
It was Anthony J. Hilder, which was like the coast to coast of Alaska at the time.
Okay.
And so he was making pretty good sense to me, and
it made logical sense.
Yeah, and I was interested in the subject anyway, so he said, just spend $50 and buy my book.
Oh, okay.
So I spent the $50 that I didn't have, scrounged it up.
Absolutely.
Book comes, I'm reading through it, and there was about 3 pages in there that just were like getting hit by a brick. And that's why I realized, that's where I saw the indirect relationships that could be exploited, where I could make a lot of magnetism for a little bit of energy. And that's where it started. So we perfected that part of it. And then it was about how to beat Lenz's law. So that started the quest.
Gotcha.
Okay, what we're doing here is with the transformer, we're actually we're just substituting a transformer as a generator. And the transformer actually eats up the power coming back into it because of the impedance matches. But it still gave us the proper waveforms and feedback input, something we can measure. So what we're doing here is this is just a standard transformer, pretend it's a generator output. And what these waveforms show you is the power going out and the power coming in and back in, and the power coming back in actually would be a motive force, and the power going out is a counter motive force. And when you add them together, what this power meter says is that's why it shows 1.1 watt. That represents a cancellation of magnetic force. So now the drag force on my generator is almost 0. It's 1/50th of what it would be to generate this electricity right now. So I actually have 52.7 watts burning on these bulbs. But if this was coming out of a generator, I'd only have require 1/50th of the magnet motive force to create that electricity, or the drag force on the generator would be reduced to 1/50th, which means basically, depending on the motor, 1/50th of fuel to get the same exact electricity. These are our prototypes we built to get our patents with, and this is pretty simple TPL type technology. We do a lot more sophisticated stuff now, and now this thing is incredible how it works. It's solid, and we haven't even taken it even close to what it can do. For the time being, this is all patented switching technology. Physics is not intellectual property. You can't patent physics, and we're strictly within the realm of known physics. So the devices, the architecture, all that's patentable. So we don't mind talking about the physics. If it inspires somebody to go out and experiment, blow stuff up, understand that, hey, this is real stuff, this isn't foo-foo. It's right there. All you got to do is go pick up your physics book and study it, and you come to exactly the same conclusions we have. So in '91, I met with my brother and Phil. They were working at Ratelco in Seattle.
Oh, okay.
Big power company. They were big power, big power guys, big power company. I came down a little demo, trying to find some engineering and some people interested. They basically laughed me out of the building, even though they couldn't prove how.
You did?
Not Phil,
no.
but the engineers did, because they couldn't figure out.
I took him out for beer.
Yeah, exactly.
And that day, Dave and Phil and I went out. We had a beer. Phil was fascinated.
Gotcha.
We made a pact that we were going to make this happen.
Oh, right on. 1991.
Yeah, and it took 10 years. Got all the kids raised, the child support paid, all the stuff. We worked on our home labs. These guys rounded up all kinds of stuff, shipped it to me in Alaska. Then in 2001, we had figured out how to do the switching. This machine design fallout, and I called them up and I said, I'm ready. I got it. Then we found
that was you got this in your head.
Gotcha. When I'd come up with this design on how to beat lengths and the magnetics, so the whole deal is the armature is invisible to the stator. The stator has all force on the armature, but the armature has no way to react back against the stator.
Gotcha.
And so it's almost, this one worked, and it's not nearly as this one. So there's a lot of engineering to improve this. But so that was the ideal. If we could get this thing, be able to flip magnets north and south, to get a switching process that didn't get eaten by the flyback, was multiple polarity, and where we could recover all that flyback energy and reuse it, as well as decouple the lens reactions.
So you're not fighting against yourself.
So we're not fighting against it.
And you can capture it back here and either dissipate it in heat or use it into the system.
Exactly.
Itself. Yeah.
And it's just straightforward physics. There's absolutely nothing esoteric about this. It's, like I said, it's all in the engineering and material science to make magnets as usable energy sources.
Yeah. And so with this system, you put in 1,300 watts, and then you get out about 1,900 watts in combined torque and heat.
Heat dissipation on the coils, right? So the coils actually...
Because you got 15 ohm coils.
Right. And so what happens is we have the switching loss and the coil loss.
Right.
And we actually built them at 15 ohms because when we were trying to get this technology up...
Yeah. You'd limit the current because you're popping transistors, right?
Yeah, we couldn't get past the first cycle, right? So, and then we figured out how to use the neons to hold balance, balance, to keep it clamped until we could get the captures. But like I said, it was our
technology's improved. This was 2000.
Yeah,
this is 16 years ago.
You saw our L8000.
Yeah.
That switch that we're selling, and
right.
It's exactly the same thing as that, only.
Newer technology.
Interesting. We don't need neon lights anymore. We've got the transitions down to nanoseconds. Right. We've got brains in it. This is all just CTL logic.
So this R&D and prototype has helped you understand that you could make a horsepower with not 746 watts, but say somewhere around 150 watts.
Yeah, and that's right now today with material science we know.
So that's just a matter of engineering and building.
It's totally just engineering and material science.
And then essentially you could turn around and put a motor that makes 746 watts with 1 horsepower and have that into a load bank and keep that system
full feedback
off of the power from magnets.
Exactly.
Essentially. And the back EMF and understanding how to manage electromagnetic.
Yeah. Well, the deal is to get, I'm a skin flint, man. I hate what, So the idea is if I get all the energy I put into it back and I reuse
Plus
it,
the force of the magnets.
plus then the magnet, so I'm getting the force. And if I don't have induction to where I have to raise the voltage because I have to overcome this thing's generating power back at me, and I have to raise voltage to overcome that, and it makes me basically, it would make me spend 746 watts per horsepower.
Right.
But this thing doesn't induce anything of force, so it's one way. So if I'm Lentz, I got two opposing forces, equal and opposite.
Right.
Well, say this is the stator and this is the armature. Well, now I take the armature and I make it a little tiny arrow. So now I'm no longer equal and opposite, right? So I don't have anything to overcome with power that's generating it back against me. So it's just strictly one-way force. So this armature has no effect on the stator, but the stator has all effect on the armature. So as this is spinning around, it can't induce any power or current, which makes drag. So as you can see, as I spin this around, there's no drag on that at all, right?
No.
So when it's running, there's still no drag on it.
Right.
And if there was drag on it, I have to overcome that drag.
Right.
And that's Lentz's law. So there's no Lentz drag. There's no oppositional forces in it.
All right. Well, I think that gives me enough.
You can go watch the videos too.
Yeah, exactly. This is a short one with here, and that's Phil, who's been working with Paul for a long time.
Many years.
Yeah, many years. So, all right, guys.